One of the most frustrating things about AI is that it's hard to know if someone used it or not. Sure, there's all the common tells like the M dashes and the you're absolutely right and the it's not X, it's Y's and all these types of patterns. But it's generally pretty hard to actually know if a given piece of text or line of code was really written with AI. And this has scared a lot of people, and for reasons that are good. If it's impossible to know what text was written with AI and what was written by a human, the world will devolve into a pile of slop really, really fast. The European Union agrees, and that's why they just introduced the AI Act, which has a specific goal of making it easier to know and label AI-generated media and text. And Anthropic is complying with it. Normally, these types of watermarks are things that only apply to media gen, things like images, videos, audio, etc., because there's a lot of data there that's relatively easy to sneak watermarks into. But when it comes to text, it's a lot harder, which is why it's pretty crazy that Anthropic's already updated their docs on this, saying that they plan to do marking of all AI-generated content across all platforms. Claude models launched in the EU on or after August 2nd, 2026 will support machine-readable markings at launch. Generated text will carry embedded watermarks, and generated files will include digitally signed provenance metadata where supported. Ooh boy. This means our friends at Anthropic will be marking not just the text they output, but the code they output as well. This is a very scary change, and I have a feeling it's not going to do what is intended. As always, there's a lot of layers to this one, from the relatively good intent of this EU Act to the questionable implementations we're going to be seeing all across the field, and also the impact this will have on us actually using the models. I'll talk about all of that, the workarounds, and more after a real quick break for today's sponsor. Picking the right database has never been more important, but it's also never been harder. You can go with industry standards like Postgres for your application or ClickHouse for your data warehouse, but how do you pick the right thing if you don't even know what you're building yet? Wouldn't it be nice if there was a great solution that combined the best of both of those? You know, like if Postgres was just managed by ClickHouse? Yeah. They're actually doing this now, and it couldn't be cooler. You get enterprise-scale Postgres with all the benefits of ClickHouse too. The Postgres database is what you should use for your apps. It's super fast and built on top of real NVMe drives on the same machine, resulting in absurd performance, up to 10 times faster for IO-heavy workloads. Where things get magic is the ClickHouse integration. All of the changes in Postgres get synced to your ClickHouse so you can do massive analytics calls without slowing down your production DB. And if you're worried about latency, don't be. Your data is replicated within seconds. And if you want to access that analytics data from the Postgres DB in your app, you can with PG ClickHouse. This would have saved my butt when I was building the T3 Chat Wrapped feature last year and I had to query data from all sorts of different places in order to pull it together. Setup couldn't be easier. You click Start, you add a new database, you get a connection string, and now you're good to go with a real Postgres database with all the power of ClickHouse behind it. Stop compromising on your database today at soydev.link/ClickHouse. The best place to start on this chaos is probably the official code that the EU has put out. This is the Code of Practice on Transparency of AI-Generated Content. There's two different sections in this code. There's Section 1 for the providers, which is rules for marking and detection of AI-generated and manipulated content, and Section 2 is for deployers, rules for labeling of deepfakes and AI-generated and manipulated text. This code was drawn up by independent experts in a multi-stakeholder process facilitated by the AI Office of the EU. It helps providers and deployers of generative AI systems to comply with the AI Act's obligations for labeling and marking of AI-generated content. Even though adherence to the code is voluntary, the transparency requirements under Article 50 are legal obligations. AI needs to be deployed in ways where users know they're talking to AI. That is totally fair. Providers of AI systems generation shall ensure the outputs of AI systems are marked in a machine-readable format and detectable as artificially generated or manipulated. The inclusion of text content here is a bit concerning. Providers shall ensure that their technical solutions are effective, interoperable, robust, and reliable as far as this is technically feasible, taking into account the specificities and limitations of various types of content, the costs of implementation, and the generally acknowledged state of the art, as may be reflected in relevant technical standards. So this is the only section that is obligatory for companies in this ruling. The rest of the code is more suggestions, but that one piece there, that section 2 here, the providers must ensure that outputs are marked in a machine-readable format. That's where this all starts to become a shit show. There's an interesting call out at the end here of the section 2. This obligation shall not apply to the extent the AI systems perform an assistive function for standard editing or do not substantially alter the input data provided by the deployer of semantics thereof, or where authorized by the law to detect, prevent, investigate, or prosecute criminal offenses. What this means is if you have an AI system that is like editing or auto-correcting or things for existing documents, images, whatever, that does not need to have the same level of like transparency and encoded metadata proving that it was AI. So if I use AI to like do a small correction, like to remove a zit from my face, that doesn't need to be marked the same way. If I'm writing an essay and I ask for the agent to find little things that I could improve in the essay or like clean up the grammar and stuff, it doesn't need to apply the same way there. But the actual output from the LLM, it does. Very interesting. And with that, we now need to talk a little bit more about watermarks. I'm going to start from a weird point, so hear me out. This image could be AI generated. It might not be. It's hard to know for sure. I don't know where this image would have been taken, but Maria posted it online on Twitter a few days ago. In fact, when Maria posted it, there was no marking here that said it was generated with AI. So clearly this photo is real, right? Let me go a step further. These two images are the same, right? Like obviously these are the exact same image with no differences between them. What if I told you there was not a single byte shared between these two images? One of these is a PNG and the other is a JPEG. This is what makes watermarking for media both really easy and really hard. That image we were just looking at, it's not huge, but it's not small either. It's 623 kilobytes. And the relationship between the size of the file and what we see, not that simple. When you have this much data in a file, there's a lot of room to stuff things into it, a lot of which won't even be perceivable to humans. Let's say I want to add some special encoding to make sure that I know this image is the one I have here on my computer. I could put it in the image metadata and things like that, but I want it to be harder to get rid of. Let's just zoom into some of the like noise and the gradient here and pick a corner. Let's just start from the top left. Why not? I'll take a random color from here. We'll take this darker purple. And now I'm going to put in a little encoding. I'm T3. So what we'll do is every 3 dots, I will fill one with this darker color. 1, 2, 3, do it. 1, 2, 3, do it. 1, 2, 3, do it. Okay. I just added a marking on this image in the top left corner where I changed one of the colors in specific pixels every 3 pixels. So 3 are left normal, then 1, I change it slightly. Can you tell any difference in this image? If you think you can, you're lying, because the compression in the video will not allow such a thing. And this is me changing the pixel to a specific color. So we do 3 normal, 1 changed, 3 normal, 1 changed. But I was changing it to a fixed color. Imagine we get a little sneakier with it. Imagine instead we take the color of a given pixel here and we knock it down or up 1 in any of the different spectrums you have control of with color, because you have RGB values or HSL, and you can change any of these at any point to or from anything. So we could have a pattern where every 4 pixels, we bump one of these by 1, and it wouldn't change anything visually for any normal person. If we just go from 30 to 31 every 4 pixels, that is relatively easy to encode in an image. And it's in a way that will not be noticeable to any human, but does accurately with the actual pixels encode real data. But in order for that type of granular encoding to work, where every 4 pixels we go up or down 1 value, we need to make sure we don't lose the pixel values. And it turns out the compression we use for media is directly in opposition of the types of watermarks we're talking about here. One of the things most image compression algorithms will do is they take areas where colors are similar and they flatten them to be the same so you don't have to encode as much data. It'll take a grid every 4 pixels and say, okay, these 4 have these colors and these brightness levels. Can we normalize that so we only have to encode it once instead of 4 times? That means that if we have this pattern where every 4 pixels we change the color slightly, that's going to be flattened by pretty much every compression algorithm ever. And all you have to do to kill the watermark is turn your PNG into a JPEG. It is seriously that easy. And I have been able to evade pretty much every single fancy type of media detection algorithm for generated AI image detection with something as simple as re-exporting as a JPEG, or just increasing the compression, or scale the image up and then back down. There's a lot of little things you can do that just destroy these watermarking techniques. And the real reason is this here. There is so much data available here that leaving watermarks in it is easy, but all the algorithms are optimizing for what humans actually see. And the difference between what data exists and what humans perceive is the problem here. With something like an image, there's a wide range of data that can be changed before a human notices a difference. This means it's easy to embed this type of metadata in an image, but it's also hard to do it in a resilient way because the compression algorithms are working around this fact that humans are bad at seeing the actual ones and zeros in the bytes. So there's a lot of hacks we can do to compress the files in order to save storage, but it also in that process would kill a lot of these hidden pieces of metadata. This is why many people who post their AI-generated images on X get tagged because they're just copy-pasting the image straight from ChatGPT. And when you copy from ChatGPT or Gemini or wherever else, they have these IDs in them. Google's went as far as creating this whole SynthID platform, which is a tool that watermarks and identifies AI-generated content, mostly images and video stuff, that they've been talking about forever. And no matter how hard I push them, they will not let me in. And I only get like 3 test runs a day using the official Gemini site. SynthID's tagging is hilariously simple. They apply this noise pattern on top of the image. GPT Image 2 has a similar one where this pattern gets applied on top and it looks that same deep fried way that GPT images look. I'm not sure if this is the entirety of how they do this check and how they do these tests, but I would guess it is a significant portion of it. These patterns are what are being used for a lot of the identification. And again, the right compression, the right application, the right layers added to it, a very, very slight filter even, which is trivial for me to add. If I just go here, filter, I can do like the slightest sharpening pass, or I add like a 1% sharpen. No perceivable difference, but now every single byte in this image has been re-encoded and any patterns that were applied on top are fully destroyed. I can even demo that trivially by copying the noise pattern and then doing a quick anything with this. I apply that 1% sharpen. Doesn't look any different, but the bytes that they're actually looking for here have just changed entirely. If I zoom in real deep and show you, see that? You can literally see the difference with like 2%. I'm going to apply now. It's a very subtle change. 0 is nothing, and then 5, you can see a slight change too. This is for like a visible noise pattern. Any of these are indetectable to humans. None of them are indetectable to AI. Like any one of those changes will entirely destroy the patterns it's looking for here. It's so easy to kill these things. It's hilarious. It's even easier if you're okay with a slightly blurrier image or you do the lazy thing, which is to resize the canvas. And see how the pattern got way blurrier? How do you think that will work if it's also applied at 1% opacity on top of something else? Trivial to destroy these patterns. There's no world in which they will persist well across any of these types of things, especially if you apply them the way they're actually applied IRL, which is something like this. Where you have it on the image as like a 0.1% opacity, maybe 1%. Yeah. You don't see any difference here. And if I blur, unblur, resize, or do anything like that, the pattern gets destroyed very fast. You could even do the stupidest possible thing, which is to just take that original image and do that with it. I just change where every pixel lands just by shortening it slightly. It's so easy to kill these types of watermarks just because there's so much wiggle room in the data. When you have 623 kilobytes, I can delete random shit and no human will notice, but the computers no longer have access to that pattern. All of this is to say this image is clearly real and we would have no way to know otherwise. So again, the problem is this gap between the amount of data and what humans perceive. And when you have images that are millions of bits, it's easy to flip things around in all directions. But what happens when you go from 623 kilobytes to, I don't know, 10 bytes? Each of these bytes is a letter or a chunk for a word. Like once you're responding with plain text that is small, your ability to hide things in it and also transform it goes down massively. If I have a 4-pixel image and I change 1 pixel, you can tell. If I have a 4 million pixel image and I change 1 pixel, you can't tell. If I have a whole book and I change 1 word, you're not going to be able to tell. But if I have 1 sentence and I change a word, you can absolutely tell. And that's where this new text watermarking comes in. I already read this section about how Anthropic is going to be following the rules. They specifically call out that the marks are going to work everywhere that Claude is used, whether that is through the API on the platform, Claude, Claude Code, Claude Cowork, and Claude Tag. They also want to help us detect Claude's marks too. They'll support users and other third parties to detect Claude's marks as the code requires. And we'll share details in forthcoming documentation. They are actually planning on adding marking to their old models as well, which is interesting to me too. As AI-generated content becomes commonplace, greater transparency and signals about where content comes from can give people useful context about the information they consume. To support transparency and comply with our legal obligations, Anthropic is working to include machine-readable marks in content that Claude generates. Embedded watermarks will apply to all generated text, and provenance metadata will apply where Claude supports processing files. This will work with all the cloud platforms too, whether you're hosting on AWS, Google Cloud, or Foundry. So let's see how they actually will be marking the content. Claude uses two complementary techniques to mark content generated and processed by AI, or by Claude specifically. Watermarks embedded in text and signed provenance metadata attached to files. First, we have the text embeds. When a supported Claude model generates text, it weaves an imperceptible watermark directly into the text itself. You won't see it, and it doesn't change the meaning, quality, or readability of Claude's responses. Because the watermark is part of the text, it will travel with the text when it's copied and pasted elsewhere, and may persist through some editing. Watermarking will be applied at the model level, which means it will be present no matter which Claude product or service the text comes from. This is a very interesting call out, specifically, may persist through some editing. Then there's the signed provenance metadata, which is that when they touch or create things like SVGs, PNGs, or JPEGs, it will provide signed provenance metadata. Metadata follows the Coalition for Content Provenance and Authenticity, the C2PA, open standard, which is used across the industry to record information about content provenance. If the metadata is present, it signals that a file was processed with Claude and lets you detect whether the file has been tampered with. Thankfully, they call out limitations underneath here. Detected mark provides a signal that content was processed by Claude, but it's not fully conclusive. Detecting a Claude mark tells you that content may have been processed by Claude. It does not on its own confirm the full provenance of the content. For example, Claude may not be the original author, because people often use Claude to proofread, translate, summarize, or convert files. The output can carry a Claude mark even if the underlying ideas, text, or data originated from another source. The content also may have been changed after Claude processed it. Marked content may be modified, exerted, or combined with other materials after Claude is processed. There's also the fact that a lack of a detected mark doesn't mean the content wasn't AI generated or processed. There's also the fact that it doesn't mean anything if it says, no, we didn't process that, because there's so many cases where it won't flag. Like if the model generated text before this was a thing, if the text has been heavily edited, paraphrased, translated, or mixed into other writing, if the passage was too short so there wasn't enough text to encode a watermark, and for the file stuff, if the file's been converted, resaved, screenshotted, or other things, again, the examples I was giving here, then it won't work. And if it was produced through a platform feature or file type where a particular marking type wasn't supported. Very, very fun. The harsh reality here is that this is only ever going to catch the lowest effort people. Because if you just copy paste the text straight out of Claude, or you have a bot that auto replies on Twitter for you and things like that, then yeah, this will catch those things. But if you put any effort in or do even the most basic of grammatical pass or changes to the text that comes out, this will be trivial to break. It is worth noting that other labs will likely be doing this soon too. Thoric called this out. Other labs will be adding similar watermarking. It's hard to identify AI-generated text, and this gives people better tools to do it. They'll be shipping a text detection API as well that we can use ourselves. All Claude-generated text will have this embedded watermarking. For example, you can check if a PR was generated by Claude Code. That said, it does have limitations. He just called out the same section we just read. We also got this wonderful example of the watermark from Nat here. Wow, the new Claude text watermarking is wild. Here we can see it making a list of totally normal, not suspicious text about search engine optimization. But if you look real closely and you use those thinking glasses, Sam Altman sucks. Wow, it's really subtle, isn't it? Back to the real world for a sec, though, because Sean Godek wrote yet another awesome piece about this, because when the act was officially announced, he had concerns. Article 50 is the thing we're talking about here. If LLM providers want to do business in the EU, they'll have to apply watermarks to their outputs, some hidden signatures that can be used to identify AI content. LLM text watermarking is a fascinating problem. Like the best engineering problems, it's theoretically hard to solve perfectly, but has multiple partial solutions, like SynthID and some quiet Unicode trickery from OpenAI and Anthropic. It'll be interesting to see how these AI labs navigate these trade-offs before the end of the year. So why is this so hard? It's easy to watermark an image because digital images contain lots of noise the human eyes cannot see. For instance, you could apply a watermark like these 20 pixels in these exact spots will always share a color. Text is much, much harder. Unlike images, text is very compressed already. You cannot make any changes to a sentence that a human won't notice, with one exception, which we'll get to later. So how are you supposed to watermark it? It's basically a text stenography problem, concealing a secret code, made more difficult because the plain text cannot be arbitrarily manipulated. Any changes you make to apply the watermark will compromise the quality of the output. For instance, every fifth letter is an E would be a good watermark, but applied naively, it would make the AI output full of typos. Could you just let the model figure out how to fit the watermark? Strong AI models are smart enough to juggle this kind of constraint, but it'd still consume reasoning time that we better spend on the user's problem and make the model sound much less capable than it is. Yep. Sorry, it's steganography. My bad. Steganography and stenography being so similar of words is humans are not good at text either. Do we even need watermarks to detect AI content? If you're Anthropic and you're required to be able to verify whether your models produce a particular block of text, can't you simply run the text through each model, measuring as you go how closely the model's predicted tokens match each token from the text? Not really. The space of all possible Claude Sonnet answers to a question is way larger than the space of all possible watermarked answers to a question. In other words, you'd get too many false positives for human text that reads like it was AI written. I know a couple people, especially YouTubers, who are hit really hard with this, where like the way they naturally speak is similar to the LLMs because those models were trained on them. And now whenever they talk, it's like, oh, that's AI generated. But in reality, they just talk in the way that the models liked and copied from them. It's way more likely for a human to accidentally write like Claude than it is for a human to accidentally reproduce a watermark. It would also be prohibitively expensive to run every Anthropic model against a piece of text in order to watermark it. The EU AI Act will eventually require labs like Anthropic to offer free watermarking services to every EU citizen. You couldn't do that with a run this model-based approach. Yep. Apparently SynthID is being used for text. Like we need more reasons for Gemini to be bad. When an LLM generates text, it's generating a series of tokens. At each step, the model itself does not output a single token, but instead outputs a full list of 100,000 tokens in its vocabulary, each annotated with the probability that that token will be the next one. Tools like ChatGPT and Claude Code will pick semi-randomly from the most likely output options in order to get their outputs. The semi-random sampling process can be influenced in a detectable way. For instance, we could choose a sampling strategy like we pick the second most likely token, then the first, then the second, then the first, and so on. To still produce high-quality output, but you'd be able to rerun the model against the generated text and verify that the pattern holds. But this makes verification really expensive, and any slight tweaks to the output would break it. Also, changes to the input, because again, the whole context window is necessary for this. So SynthID does this instead by assigning a score for each token based on the previous tokens. To apply this watermark, the model adopts a sampling strategy like out of the top 5 most likely tokens, pick the ones with the top SynthID score. The watermark can then be detected by calculating the aggregate SynthID score of a block of text. If it's suspiciously high, it's very likely to be AI generated. This is similar to noticing a lot of M dashes, but instead of a list of keywords, it's subtle math relationships between things that humans can't identify as well. And since it's trivial to assign the scores, it's trivial to run the watermark detection. The other strat people have been using are these different space characters. There's a lot of different ways to encode a space in a thing that are not just the normal spacebar press. Humans will not see it, but if you encode these strategically inside of something that an AI model writes, you can detect which ones are where and use this to get real useful data. I remember Vercel a while back was working on a feature where you could edit content on a blog or something via the Vercel toolbar. And the really clever strategy for linking different pieces of text in the UI to the official like CRM backing it for your blog or whatever was to append different white code text at the end of each paragraph so that when you selected that text in the UI and you made changes, it'd be able to map it to a different place in the actual database simply by detecting which row it was with an identifier using these different Unicode space characters to hide messages inside of the UI. It's very clever and really cool, but also like easy to trim out too. If you were to use different space characters to apply watermarks, it would be very cheap to detect, but also easy to filter out too. Claude Code is apparently doing this in the past to tag suspicious requests from Chinese users. In the last few years, they've noticed that when they copy blocks of text from ChatGPT and paste in the VS Code, sometimes VS Code marks some or all of the spaces as unusual Unicode characters. Are OpenAI and Anthropic using homoglyphs as AI-generated watermarks? The author's not sure, but they're definitely using them. Interesting. But the problem here isn't whether or not they're easy to add, it's how easy are they to remove. because all text watermarks can be trivially removed. If you use these Unicode homoglyphs, it's trivial to just replace them with the original character. Now you're out of it. Watermark gone. If you have access to even a relatively weak unwatermarked LLM, you can strip out the SynthID watermarks by asking the LLM to paraphrase the text content. Because the watermark is inherent to subtle vocabulary choices, rewording the content will remove that watermark. You could even do it by hand, although at that point it's not really AI-generated content anymore. Since there will be some kind of free public watermark testing tool, you can just keep tweaking until it comes back negative. Yep, that's the other problem. If it's easy for us to check if text is generated or not, that works on both sides, both for us reading the text and also for people trying to generate AI text and get it out there looking like normal text. Moreover, the AI Act requires watermarking techniques to be interoperable as far as it is technically feasible. That means AI providers will have to publish their watermarking process and potentially even attempt to standardize on applying the same kinds of watermarks. The author does not see how this is compatible with the kind of security by obscurity that LLM text watermarking depends on. You can't be obscure in how you implement it to hide it, but also give all of these tools. Like there's a have your cake and eat it too, by the way, the cake's invisible and all made up type thing here. Then we get to C2PA, which is honestly one of the stronger things in all of this, but not because of how it makes it easy to verify AI content. We'll come back to C2PA in just a moment. The AI Act in Code of Practice talks a lot about digitally signed media. The idea here is that you can include an AI disclosure in the file's metadata itself, ideally in a way that cannot be tampered with, like signing a hash of the file's contents. The signed metadata process is basically the C2PA content credentials. While you can remove C2PA metadata, you can't fake it. So a file created by human metadata can be trusted, and a file with no metadata at all can be held in suspicion. Okay, this is the part that I actually wanted to bring up here. The thing that makes C2PA strong isn't that it's flagging AI gen content, is that it provides standards to identify human-generated content. And that's the only direction that makes sense here, especially for media. It's a lot easier to sign something as really generated by the chip on your camera with a photo you took than it is to detect all things that weren't taken on cameras. And the more ways we can find to sign human-generated media, the easier this gets, because I really do think long-term that's the only solution that's going to work. Sadly, the C2PA created by human markers are not going to solve anything in text. It only really applies to files. In the words of the Code of Practice, that's, quote, a data format that supports attaching metadata, like audio, image, video, or containerized text. The output of chat tools and most of the output of AI agents is not containerized text, but plain old regular text, so it cannot be signed. What would it even look like to sign a ChatGPT output? There's no artifact to pass around. I think it's a fascinating question whether the Claude code has to C2PA sign any HTML files or PDFs it generates for you. Seems kind of tricky to get right. But in any case, the AI Act also mandates some kind of actual watermarking as well. And the harsh conclusion here is that no matter what happens, technical users will be able to strip out the watermark at will. And there will be a plethora of tools for non-technical users that will do the same thing. We already have a bunch of repos that are doing watermark removal here. Unicode text hygiene, statistical rewrite hooks, and C2PA metadata removal from PNG, JPEG, SVG, PDF, docx, HTML, and MD. This is a real repo that already exists to remove watermarks from AI-generated things. It's an agent skill and a standard Python script to strip multi-vendor AI provenance marks from text and files for privacy and hygiene on content that you own. They have a skill you can install if you want to remove AI marks from things that are generated by the same agent in your code base, by the way. So you can literally ask Claude to remove the watermark from Claude's outputs, which is hilarious. Yeah, to conclude on my end, the issue here is that this is a really shitty cat and mouse game where the mouse has all of the advantages. It's way too easy to work around these things, and it's way, way too hard to do this type of watermarking in a way that isn't trivial to bypass. Like, I just cannot fathom any method where you can watermark text that isn't either incredibly expensive to detect or incredibly cheap to work around. And that catch-22 is pretty brutal, and I just don't ever see it working out. All this will ever do is catch the lowest effort spammers. People setting up bots that just use Claude or other models to spam people on Twitter and whatnot. And they can all move to cheap open weight models or add really basic checks in front. But this is not going to stop anything. This is one of those things where it like sounds really good to normal people, to voters, to politicians, to all the people involved in making these processes. It sounds like a really good idea. We should be able to detect what text was generated by models. We should be able to detect when an image was edited by an LLM. Like, obviously, we want these things, but we literally cannot do it. We have to think back on what our goal is here. Is our goal to make it slightly easier to notice when a random person copy-pastes an output from ChatGPT? Is our goal to make it harder for students in high school to cheat on essays and have ChatGPT generate them? Or is our goal to get in front of people using AI to do destructive campaigns across society, like a government using it to spread propaganda and generate a bunch of messaging that aligns with them? I think this will help a little bit with the stopping high school cheaters, but I don't think it's going to help with almost anything else here, because any medium or even like slightly higher than zero effort attempt to mislead people with AI generated stuff will not be stopped at all by this. And even the high schoolers are going to find workarounds if we're being real here. So I don't see this being useful. I see this being one of those things that sounds really good, especially to normal people that are getting tired of AI slop destroying everything around them. But I just don't perceive this as a thing that will work for any real use cases. And I think that we'll get over this watermarking phase relatively quickly. What we're going to have to do is start verifying when images are real instead of fake, and educating the public about the fact that there are many things that look real and aren't. Unlike the image I have on my screen now, which is clearly a real image of my face on a leg. But generally speaking, the education side and flagging of human content is what we need long term. That's all I have to say on this one. I honestly wish that the effort of these really smart people was put into things that would actually work. I know this is a good faith effort to try and make it easier for the public to adjust to a world with more and more AI generated stuff, but these efforts just aren't going to work. Even a very basic cursory understanding of engineering and watermarking techniques makes that obviously the case. How do you guys feel, though? Is this a net positive, or is this just a waste of time? Curious how y'all feel about it, and until next time, peace nerds.